creating our class using the object literal syntax is going to allow us to have a lot of control over where we go here. Now, as we set up information and are using a sprite sheet, we're going to be referencing things a little bit differently than we may have done prior. So we have x and y's, widths and heights and all of that, but when we're working with a sprite sheet, we need to have a source x position, so that'd be the top left corner of each frame, and a source y position. And we will need to then have the coordinates of where is our object on screen. It's x and it's y as we want to draw that object on screen. So as we put this information into our object literal, we're going to need more pieces of data than what we've had before. So we're going to have a source x, and when we're defining the class, what is useful is we pretty much define everything just with the 0 value. So we at least put a value in, but we don't need to give it a particular value yet, because we may be able to use this class for multiple objects. And that's where we'll be modifying what we do here. So we'll make one sprite object class, and then we can create instances of it for all different sprites within our game. So this one sprite object class is going to get more properties than any one sprite may need. We may not use all those properties. So we just start out and put in a bunch of properties, put zeros on them, and as we add in new properties to that sprite object class, we will then be having to update our code accordingly. But it's a way that we can just keep growing it, and it will serve us down the road. So we'll have a source x and a source y. They'll both be at 0. We'll have our destination x. That's going to be where we will be drawing the sprite on screen. And we'll have a destination y value for where we will be drawing that object on screen. And this is where things can get a little bit interesting. We can have our sprite with, and apparently I lost my ability to type, and I can have my sprite height, and this is the size of the graphic on the sprite sheet, on our atlas. But we will also have a width and a height value for the sprite, because while we will draw them on screen at a certain size, the original artwork may be bigger or smaller than how we're choosing to draw them on screen. So we will have the sprite sheet height and width, and we will have the actual height and width of how big we want this object to be when we draw it on screen. Now, we're also going to need to specify how many frames our object has, and it's always going to have at least one, so we'll just default at 1. And it's going to have a certain number of columns, and it would have to have 1. Looking at my atlas, I will see it's a 3 by 3, 3 columns and 3 rows. But I'm writing this generic for now, because then when we create a new instance of the face, we will populate all these values with the correct numbers that we need for that particular instance. Now, I have frames, I have columns. We probably are also going to need a speed x. I'll just start that out at 0, and a speed y. And we'll start that out at 0 as well. Oh, I forgot something else. Before the speeds, next to frames and columns, we want to define our current frame. If I look at my texture atlas, the first frame is 0. Then I have frame 1, frame 2, 3, 4, 5, 6, 7, 8. So 0 through 8. Computers like to count from 0. So I have 9 frames, 0 through 8. So our current frame will be 0 as we are working on it. Our total number of frames, well, right now it'd be, we can say it's 1, but we know when we create a new instance of this, it will be 9. And it will be 3 columns. So if I say this is 9 frames and it's 3 columns, that means the computer will know it's going to have to go through all 3 rows to generate my full animation. So these are the properties of the object that we will be working with. And we can certainly add more properties as we add to the project. But for now, that's going to give us a good starting point. Now, the next thing we want to do is add in some methods. These are the functions that we are providing. So I'm going to say update frames. And that will be a function. And I'm going to create the 3 functions or methods that will be part of this. We'll update frames. I like the plural there. And the next one is going to be move. And my final method that I will add will be display. And on that final one, you'll notice I did not put a comma at the end because it's the end of this comma pair value list. And as we fill up these 3 methods, we may end up with lots of lines of code. So it's useful to put comments on the end statement so we know which curly brace goes with which entity. It will allow us to keep things a little bit more clear and updated. To make sure that we're on track, what we're going to do is we're going to just fill out display, and then we're going to create a new instance of this object and then try and make our program run. Because once we know the display is working correctly, then we can worry about adding in the animation. Then we can worry about adding in the movement. So the first thing is to worry about display. And under display, we tell our context to draw image. And the image that we want to draw is going to be, let's see, what did I call it? I called mine face image. You can call yours whatever makes you happy. Now I'm adding in some extra line returns here just for readability's sake, because realistically all of this is taking place inside the set of parentheses. So we don't have to have it all on separate lines, but I think it makes it easier. Now we will run into an instance where we have to use the word this once more. And I say this, my source X, this, my source Y, this, my sprite width, whoop, don't put that space there, and this, my sprite height. So that is my source coordinates. Now on my next line, this dot dx, this dot dy, this dot w, this dot h. And this is my destination coordinates. With my display method defined, my core variables defined, now I'm going to create an instance of my object. And as I go to create the object, I can use our var statement. Just call it face is equal to object dot create. I prefer to always have my classes defined with a capital letter, so that's var capital F face. Face. So lowercase face, that's an instance of my face class. So that now creates that object. And once we've done that, this is where we need to populate its values. Face dot, and this is where we will go through and populate all of those values. Now, if we don't put a value in, it defaults to whatever number we've put here. So if I don't define any of these, which we'll correct these to, so it's 9 frames, 3 columns, and 32. It's all 32. Speeds, current frame 0. None of that matters. And draw it up in the upper left-hand corner. Face dot display. So as I look at this in the browser, it tells me unexpected token. It's really common when you're doing object literal syntax. Out of default, you hit the end of a line, you type in a semicolon instead of a comma. So let the browser help you. Image is not defined. On line 15. Oh. And now we can see it drew the face in the corner. So it used the default values that were part of the object literal definition, and it drew my object, so I didn't have to define any of its properties. But if I use this class to define multiple objects, or if I want them to now have different values, if I wanted to put 10 or 20 of these on screen, each one at a new location, I can't rely on those default values. Instead, I need to be setting it each time with my object. So it's a different way of needing to work with it. For just one, okay, that's fine. I can define them there and hard code it in. Otherwise, what we want to do is say my source x is equal to 0. My source y is equal to 0. My dx is equal to start out at a random location times 600 plus 100. So that gives me from 100 to 700. That'll work. Face.dy is equal to math.random times 400 plus 100. So we can see each time it loads, it's going to put it into new location. After I have put in my locations, then it's my sprite width is equal to 32, space sprite height is equal to 32, my face that width is equal to And now we could use that same number, or I can now set it equal to base.sprite. I'm just going to, 32 is faster to type. Now this seems like a lot of redundancy or extra work because we only have one element. But if I had 10 different sprites of different sizes and frame counts and columns, then we would suddenly go, okay, this makes more sense. I just have one class that is applicable to all of them. Current frame will always start at 0. Speed x and y starts at 0, so we can leave that. All right, so that now defines the values for my sprite. And I can go back and nuke these, or I can leave them. It's no harm, no foul at the moment. When I put back in, except I'm going to set frames and calls back to 1, because I'll easily forget that later. If we go back and test and see that it's working, all is good. To update the frames of the animation, what we have to do is we have to use some basic commands to loop through our frames. So we have to tell it how to update this dot sx is going to be equal to, and we need to make it move over one frame. This dot sy is going to be equal to make it move down one row. Actually, let me change this from frame to column. If we think in that context, that works okay. Now we need to move over this dot current frame. It's going to be equal to, and we need to make current frame go up by 1. Current frame starts out at 0. We need it when it gets to 8 to go back to 1, or I mean back to 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, 4, 5, 6, 7. So we need to set up this looping syntax. And we can do it where we have, where we make it go one bigger, and then we use an if statement to find out if we've hit the top limit, and if so, then we reset it back to 0. So we can do it that way, but in this instance, because it's what we need to do for one of the other lines directly above it, we're going to use the shorthand syntax. This dot current frame plus 1, and now we will use the modulus math operation, which is a percent sign, and we are going to divide by the number of frames. So modulus says divide by a number and then keep whatever the remainder is. So current frame starts out at 0. So then we say current frame, I want you to be equal to current frame plus 1, which would be 1, divided by the number of frames. In this case, 9. So 1 divided by 9 is going to be 0 with a remainder of 1. Then we say current frame, I want you to be equal to current frame plus 1, okay, 2, divided by the number of frames, 9, and we keep the remainder. We throw away whatever the other part is. Oh, that means it's 2. We continue that process. So 8 divided by the number of frames, 9. Okay, that gives me 8. Now 9. 9 divided by 9 gives me 1. Throw it away. And a remainder of 0. Go back through. 10 divided by 9 gives me 1 with a remainder of 1. And we keep going. Then 2, 3, 4. And then we'll be all the way up. So 18 divided by 9 is 2, remainder 0. We throw away the 2, keep the 0. So the modulus math operation is we keep a hold of the remainder. We don't care what that whole number is, 0, 1, 2, 1. It doesn't matter. We want that remainder, and that gives us a permanent looping set of numbers. So this one line of code keeps current frame looping 0, 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, etc. until the cows come home. To move our frame over and march it over a row at a time, we will say math.floor, and then this.current frame modulus. This is why I talked about modulus on current frame before, because it was easier to keep track of. This dot columns. So we're dividing the current frame by the number of columns. And then we are going to multiply it by the width of the sprite as we're going to work with it. Actually, it should be the sprite width, sorry. So if we think about what this is happening again, current frame is 0. 0 modulus the number of columns. Okay, that's 0 times the width of the sprite. 0 times anything, still 0. Okay, the first time our source x will be 0. Now when current frame is 1, 1 modulus the number of columns, that will be 0 remainder 1. 1 times the width of the sprite is then going to allow us to move over to set our source x to that next column. 2 times the width of the sprite will bring me back over to my column right there. And now if we go 0, 1, 2, now 3 modulus, okay, my number of columns in this case will be 3. 3 modulus 3, so 3 divided by 3, remainder 0. Oh wait, that puts us back to this one right here. Then 4, then 5. 6 will put us over here, then 7, then 8. And then we go back to 0. So we can see how this line here, because we're using divide by the number of columns, but keep the remainder, it creates a secondary loop, much like this loop 0 to 8. This is going to do loop 0, 1, 2 in this particular instance of 9 frames, 3 columns. Code is going across columns, and we can't see the difference because our atlas has no change across the first 3 columns in row 1. It's a pretty lackluster thing to say, update frames. Woo, nothing happened. So what we need to do next is we need to figure out how to update and make it move down 1 row. So instead of starting it out at 0, we'll once again use math.floor. And we're using this math floor because we need to make sure whatever number is being generated is going to be a rounded down integer, a whole number, because these values, our sprite sheet is defined in whole pixel values. We're not using fractional pixels as part of this, so we need to make sure the numbers match. That's why math floor rounds down, and because the computer is always starting at 0. Top left corner in our atlas is 0, 0. It makes sense to always be rounding down. We don't want to have any fractional things extend beyond it. And we'll use current frame again, but this time, instead of using modulus, what we're going to do is we're going to divide it by the number of columns. And then we will multiply that by the sprite height. So if we think about what is happening here, current frame starts out at 0 divided by the number of columns. Columns in this case is 3. 0 divided by 3, okay, that's 0. 1 divided by 3 rounded down is 0. 2 divided by 3 rounded down is 0. 3 divided by 3, well, that's going to be 1. Rounded down, it's still 1. So that means our source y multiplied by the height is now magically we're in row 2. And then 4 divided by 3 rounded down is 1. 5 divided by 3 rounded down is 1. 6 divided by 3 is 2. 2 times the height puts our y coordinate down here. And if we remember that 0, 1, 2, 3, 4, 5, 6, oh, there's current frame 6, so that we can see how these numbers are magically, wrong key, are magically lining up to cycle through. So it moves it across one column, moves it down a row when it's necessary. And now if I save this and load my file here, I hurried to define my object literal, and to get this whole sprite animating, I forgot to actually add in a request animation frame statement. So if we want to set this up, we now need to figure out how to go about doing this and putting it into our project. So we can say window.request animation frame. And I'll just tell draw. So I put a little line of code that I didn't really talk about before in here that's used. I have window request animation frame calls the draw function. The draw function gets called in the beginning after face image has loaded. So I attached an event listener to the image and said, when your loading is done, call the draw method or draw function. So then draw function gets called, window request animation frame calls it, and now it starts updating.